Now we talk about LaTeX mathematics fundamentals. Okay. One of the strong points of LaTeX, like we found out earlier, is that it is very good if you're working with equations, maybe like a mathematician, a physicist, or even a chemist. All these chemical equations can be well done in LaTeX for sure. Okay. So now let's get into some how we can do mathematics with LaTeX, how we can typeset mathematics with LaTeX. All right. Our objective is includes the following to typeset inline and display equations accurately using appropriate environments, align number and reference equations according to academic standards, format matrices, vectors, fractions, roots, and delimiters professionally, define new mathematical operators and macros for repeated use, create elegant, organized problem sets and mathematical documents. So imagine that you want to do an academic paper or you want to set questions for your students and things like that. So this is what this kind of thing will do for you. So the mathematics environment, LaTeX separates mathematical content into inline and display environments. So inline math is used within text. So let's say you're just talking and then you're just going on and you want to just mention the equation as well as what you're saying. And then there's also display part, which display math is used for equations on separate lines. So for display, now you want the equation to stand out. All right. For inline, you want the equation to be together with your text. But then for display, you want the equation to stand out from every other thing you're saying. All right. So for inline, you can use backslash bracket, write whatever you have to write in between, and then backslash close, backslash open bracket, three dots, backslash close bracket, open close, right? Or you can use dollar. So these two will do the same. For display, you can use backslash square bracket, write whatever you have to write, and backslash close bracket. Or you can use double dollar. So that would do that for you. So a very good example is maybe you're just talking and you write Einstein's famous equation is blah this like this. So you can do this or this. It gives you the same result, right? In fact, thankfully, anything about dollar can be rendered in this place. It can be rendered accurately in okay, I guess I have to. So anything involving dollar can be rendered directly in this uh markdown. I mean, what's this called now? Mm, Yeah, it's called Markdown, of course. It's called Markdown. So in this Google Colab, so this is dollar. So dollar can work here directly, but this other one won't work here, but it will work in LaTeX. So I do anything that can work here, I put it here. So Einstein's famous equation is okay. I don't need this all in this case because of editing. Good. So Einstein's famous equation is E equals mc squared. So this is inline now because the equation is together with the sentence you're writing. So it's more like you're writing a paper and just want the equation to be part of the sentence you're writing. But if you want it to stand out, that's where display comes in. So you should use inline mode for small expressions inside sentences, like we said before, okay, within text. But for display now, okay, Einstein's famous equation is you now want to display this. So display means that you want the equation to stand out from the sentence you're making. All right. So in this case, since dollar works here, so I'm going to copy this and bring it outside of the LaTeX formatting. You know, this three dots with LaTeX now makes this one not to run like this here. But if I write this one separately now and put the dollar thing, so you'll see how the equation stands out. And that is what we mean by display. Okay, that's what we mean by display here. Of course, we are going to have a final, we are going to have a mini project where we do all this, we demonstrate all these things. So you see, unlike here where you have instance for my famous equation is E equals mc squared. Here, instance for famous equation is, so it stands out separately like this, right? So, so this is inline together with the text, display that which stands out from the text. So you can either use the double dollar sign or you use backslash square brackets, backslash open square bracket, backslash close square brackets. or double dollar sign. So the professional tip here is you can use backslash open square brackets with whatever you have to write in between, then backslash open square bracket, and they don't have to be on the same line as you're going to see when we get to the mini project. Then instead of double dollar, you can use, so this helps to save space more than double dollar signs. So, but then the two of them can work equally for display maths. Okay. So display makes equation stand out. Inline makes equation go together with the text you're writing. So let's talk about equation numbering and referencing, equation numbering and referencing. So use the equation environment to number equations automatically. So because I put this in formatted LaTeX environment, now you won't see the number, the equation number, but let me put it above this so that because this can actually work here. So you see the equation. Okay, what's happening here? Yeah, begin equation and equation. It should be numbered. I'm not saying the number. Okay, that's fine then. So let's just so let's wait till we do the project. I mean the mini project, and then you see all of these things playing out. Okay. So you can number your equation. So begin equation, end equation, especially if you're dealing with one equation. Then you can also label your equation and reference it. For instance, in this case now, labeling and referencing. So, here you just have begin equation and equation, and then you have the equation in between. Or here you have begin equation, end equation. All right. And of course, since LaTeX has this kind of environment, anytime you're using begin something, end it immediately so you don't forget. So begin equation and equation. The equation itself is F equals F MA. But because you want to label it for referencing later, and then you come here to reference, say, as shown in equation. So because you have labeled it as EQ Newton, so as shown in equation, then REF now is what you use to reference it. So REF EQ dot Newton. So you can use REF or EQ REF. So if you want the equation number to be in bracket, you use EQ REF. If you don't want it to be in bracket, you use just REF. So, and then you say EQ Newton. So this same label now. So force is proportional to mass and acceleration based on what this is giving us. So the mini project to show us all of this. Now, what if you want to suppress equation numbers? You don't want to see equation numbers. So you can suppress equation numbers by just doing this. So you have begin equation and you put star here. Just like you remember in the last video, I showed how to suppress section number. So by saying backslash section star star open braces, close braces, and put whatever you need to put inside the braces. So, but in this case, you don't put it after begin, you put it after the equation. So if you don't want to see equation number, so you have begin equation and equation with this star star, and you have E equals MC squared. Then you can align equations and multi-line layouts. I mean, one of the most versatile tools I've come to learn to use in LaTeX is this align. Align seems to work for everything. It works for single equation, multiple equation, and anything you want to think about. So I guess you use align a lot. So sometimes, I mean, it's been a long time. In fact, there's actually equation array too. Let me add this. So we can actually use equation array for more than one equation. Like this. Let me see. So this would now be EQN array. EQN array. Hope I remember to use this when we get to the mini project. So if you can use this for several equations. So like you have E equals MC squared, all right, and then E equals MC squared, right? Then double backslash. Then you now have say X is equal to, or better still, AX squared, your quadratic expression, BX plus C equals 0. Okay, so this works. Begin equation will not work for this, but equation array will work for this. I want to try it out here to see if it actually gets to work. Yeah, you see it works. It puts the equation in two separate lines. So in this case now you can even put if you want to align it with this, so you can put and here, ampersand. Let's see if that works. Ampersand helps to align the equations. We're talking about alignment. So you can see they align at the level of equality. But if I want a proper alignment, so I can put and before and after the equality, okay, so that they align along the equality sign. So you see, everything aligns perfectly along this equality sign with this and I have before and after it like this. So equation array will do this for you. But the only thing is that it's not showing the number. So Number is not showing here, but when we get to LaTeX proper, you see the equation numbers showing. All right. Then we have labeling and referencing. We've talked about that. Suppressing equation, we've talked about it. Okay. So aligning. So like I said, align is one powerful tool I've learned in LaTeX. So aligning equations are multi-line layouts. So here now you have more than one equation, like I said before. So here now, this one is under LaTeX formatting. So, but I can actually bring it out of that and then do it because some of this equation can actually, so you can see we have A plus B equals C, D plus E equals F. All right. And so this works about, yeah, we're not seeing the numbers. So here now you can use and for alignment points and double backslash to separate lines. So you can see when you have more than one equation, that double backslash keeps coming, and then the and, like you can see here, double backslash here, and then and to align the equations. So those are very useful like that to align stuff. Then you can also gather, you can use the gather environment. So what gather environment is doing is more or less like what that equation array thing did the other time, I believe. So you're gathering equations or something like that. That's what I see it doing. All right. I guess we can also use the so we can use the and ampersand, to align. Okay, so this one looks like I need to use it on both sides. So probably I need to use it on both sides to make sure they align perfectly. So that's and now. Okay, that's why if you want and to really appear on its own, you need to put backslash because and has a special work it's doing. So anything that has a special work that it's doing, like percent, hash, underscore, braces, if you want them to really show, you need to use backslash to escape them. We saw that in the previous video. Then you can have a multi-line environment. So if you have a very lengthy equation that you want to apply, you want them to appear in multiple lines. So this multi-line environment thing works. So you just have begin multi-line, end multi-line. So this, I think this should work here. Now the problem is the so the other part shows up in a very in a distant place. But of course, there are other ways we can actually we can break things down. For instance, I think we can even use what's this thing now? Um, is it begin split and end split? I think. So let me try begin split and end split. I think that's another thing that works. So begin split, end split. Let me see if it works here. So I just say begin split, end split. Let me see if it actually gets to work here. Normally I should try it up there first before I bring it down. If it works, then I bring it down. Okay. Begin split, end split. Yeah, no, this is a final way of splitting, right? Than what it was before. So begin split, end split. So this one, the distance is just too far away for multi-line. Okay, so begin split, end split can actually work this way. In fact, if you like, you can even align it. You can align it with the beginning. So in this case, now we just have like we have. So for this begin split end split, I just put and here. So and make sure those two things align where exactly you have put the and. So you see now that from X1 now, so this equality now aligns with that. So depending on what exactly you want it to be like. So you see begin split seems to make more sense than multi-line because multi-lines, everything is all over the place. So I have and here for alignment purposes. So don't forget your and for alignment and don't forget your double backslash for break. Okay. Then we have sub equations for grouped numbering. So if you want to maybe number your equations like 1a, 1b, 2a, 2b, so you can use begin sub equations. So maybe if you number your equation 1, equation 2, equation 3, and now get to equation 4, you want it to be 4a, 4a, 4b, 4c. Okay, so you can use this. So this produces numbering like 1a, 1b. So you use begin sub equations, so you now align the two equations, and then so begin sub equations, then sub equations, then begin align, end align. Then you have f equals me and e equals mc squared. So of course, because this can work in the regular Markdown environment in Google Colab, you can bring it out of the LaTeX formatting. So this triple LaTeX thing makes it look exactly the way you should paste it. You should write it in LaTeX. So That's why we left it that way. So you can see how exactly it should be in LaTeX. Oh, this isn't working. So what is the trouble? What should I have done here? Okay, so if that is not working, then we can let it be. This can go then. We can just leave it alone. Leave it alone. Okay, so now, but in LaTeX, this is exactly how it should appear. You're going to see it when we look at the example. Then what about mathematical symbols and expressions? So if you want to deal with fractions, so dollar works here, right? So I know whatever backslash open close square brackets backslash close brackets will do. That's what double dollar sign will do. And double dollar sign works in Markdown. That's why. So you see exactly the equation is what you have, except that double dollar can actually, you can see directly here. But this one, you can see both double dollar and this one in LaTeX when we get there. So now this is going to give you A plus B over C plus D. This is fraction right now. Interestingly, there are two types of fraction. You have the regular fraction and then you have diffrac. So if you think what the fraction is too big and you want to see it more clearly, you can put D in front of frac. So you have diffrac and see the difference. Okay, I think the difference doesn't seem too clear here. But when you get to tech, when you get to maybe text studio overleaf, you'll see the difference. This is somewhat bigger than this usually. All right. So that's what diffrac does. Okay. So that's for fractions and exponents. So for exponents, you have x squared e raised to power I pi plus 1 equals zero. That's the Euler identity. You see Euler's identity. So then for roots now, so for roots, double dollar will do square root. So for roots, you have backslash sqrt a squared plus b squared and in braces. So sqrt. Then this quad is to space it, and then you have sqrt. So sqrt 3 x plus 1 means the cube root of x plus 1. And here now it's just regular square root of a squared plus b squared. Okay. So that is what we have there. So square root a squared plus b squared. So of course this is a normal square root, right? Except that if you really want to show that you want to go all the way to show that it's a square root, which is not necessary because once you see square root without that, so you know it is already square root. So, but anything apart from that, you need to indicate it like we have to talk about this here. Okay, and so this is another way to this is the way to render it in LaTeX. Of course, you can also do it with double dollar sign, but double dollar sign works here. That's why I showed that straight up. Then you can also work with summations and integrals. So you have summation from I equals 1 to n of I squared, or integral from 0 to 1 of x squared dx. So so this is one other way to render it. So I did this using dollar. Okay, backslash sum underscore all this. But since it can show here, I showed it straight. And then this is another way to show it in LaTeX. Then you can work with Greek letters. So alpha, beta, gamma, delta, and all the rest of them like that. So you can see this is me using double dollar sign here. And the same can be done using this backslash open square bracket, backslash close square bracket. So this is alpha, this is beta, small letter, this is gamma, small letter, this is gamma, capital letter, this is delta, big letter, this is pi, this is omega, big small letter. This is theta, small letter. This is theta, big letter. Okay. So I guess I need to remove one of this. Of course, if you want to add, so this is big pi now. So what if you want big small? I mean, this is small pi, what if you want big pi? All right. So that's big pi. Then I can add that. Oh, sorry. I can add that to theta right here. So you see, this is big pi now. Okay. Let me add one more. Let's say I want to add psi. See, there's still psi, there's phi. Let me add it to small letter and big. So we have backslash psi. Okay. Backslash phi. Okay. And then backslash psi again. That's big one now. Then backslash phi. Okay. So but that should be backslash psi phi, yeah? So I just bring all of this together, okay, and then also add it here. So we can see this rendered directly. So alpha, beta, gamma, delta, delta, pi, omega, theta, big theta, this is big pi, this is psi, phi small, and this is psi phi big, like that. Okay. So interestingly, in the next video, I'll be focusing basically on some mathematical symbols, I believe. So piecewise functions now. So a piecewise function, if you know some maths already, a piecewise function is actually a function that has different values within different intervals. For instance, you have f of x equals the f of x will be is x squared if x is greater than or equal to 0, but it is minus x when x is less than 0. That's what this simply means. So if it is x squared when x is greater than or equal to 0, when x is less than 0, it is simply minus x. So because I can do this in dollar, that's what I did now. And then with this LaTeX thing, so you're able to see how exactly you should render this in LaTeX. Okay. So we can do piecewise function. We're talking about special mathematical symbols and expressions, as far as LaTeX mathematical fundamentals is concerned. Now let's talk about matrices now. So for matrices, you have of course, this is what the dollar one can do. So these are different types of matrices. So if you talk about P matrix, that's normal parentheses. If you talk about B matrix, that's bracket, that's square brackets now. And if you talk about V matrix, that's like you're looking for determinant of a matrix. And if you talk about capital B matrix, you have this curly bracket thing. And then if you have capital V matrix, it's more like you're looking for the norm of the matrix. All right. So that's how that goes. So apart from double dollar, which I used for each one here, all right, double dollar for each matrix, you can actually use the backslash, I mean the what is it called now? You can use the backslash open square bracket backslash close square bracket exactly the same thing, and it's be done. Therefore, column vector, this is the kind of thing you have. So you have column vector. So for double dollar, right? In fact, let me also copy this for the next one, which is row vector. So for column vector, you have this. So see how it's defined. So backslash vec v equals, so vec v is what makes the vector to have an arrow on top because it's a vector. So it has magnitude and direction. So begin matrix 1, 2, 3, and you have this whole thing. Okay, that's a column vector. So we can actually do row vector, which I didn't do before. So I can just come here and say this is now row vector. All we just need to do is to change the direction. So instead of doing for row vector now, it's just straightforward. So we just have 1, 2, 3 in a line. 1, 2, 3. So just with space. We don't do okay. Okay, maybe I need to now do quad in between. Quad between 1 and 2, then quad between 2 and 3. So quad brings some spacing into that. So this is row vector now. So I have to copy the same thing between the open square backslash open square bracket backslash close square bracket. Okay, I mean this should come here. Okay. All right. So this is row vector now 1, 2, 3. Okay. Then for determinants, of course, I think I also showed it here. So for determinant, that is I think that's small v for determinant, I think. Yeah, I think it is, yeah, small v. So for determinant, let's see, maybe this must have been done in another way. So, oh, okay, it's that small v, interestingly. Okay, so you just say determinant A equals begin matrix V matrix and V matrix and declare a matrix. So you see how the matrix is declared A and B. So if you want to declare a 5 by 5 matrix, you just say A and B and C and D and E, then double backslash F and G and H and I and J and so on and so forth. So so you need to understand this syntax. So this is for determinant right now. Okay. And then we also have delimiters, right? Delimiters, they are like things like brackets, square brackets, and all these things. So imagine this here now. So say left. So I mean, this is really powerful, this left and right thing. So some people still use the old style where you have to write backslash big, like BIGG or capital BIGG. So all of that can work, but it's a lot, it's too much of stress. But if you just put left and right, it automatically covers the whole thing. So if you don't use the right big, it may not cover what you need to cover, right? So but in this case now, by just saying left and right, so left bracket, right bracket, and then you write whatever fraction you want to write in between. So just takes care of all of that, and then you go your way. So this kind of brackets, so you see the normal bracket, square bracket, and now you see for the braces now, you see you have to use backslash because normally if you don't use backslash, that will not show. It won't show because they have their special, in fact, it spoils the whole thing. So you have to use backslash because you want those to show basically. Okay. So, and this is another way to render the same thing. Then talking about defining, you can actually define math operators and macros. So you can define how you want certain things to appear. So in that case now, you can have custom operators where you use math package, AMS math. So anything math you want to do in LaTeX, you need to have math packages like AMS math, AMS symbols, sometimes AMS fonts, AMS theorems. If you're working with theorems, I think in the subsequent video, we're talking about theorem environment. So you see how all of that goes. So imagine you want to declare math operator var is variance, declare math operator curve is covariance, declare math operator rank like this. So then you can now say, okay, that the variance of x is equal to curve of xx. Something like this now. So I mean I can just bring this out and do it in use double dollar so we can see it directly from here. Since double dollar can work in this Google Colab environment. Okay, okay, it's not okay. I mean it's not working here because I think it will work on LaTeX, not here. Yeah, get it. Then we can also, so these are custom operators. We can also have custom macros that anytime, so once you have backslash R, it automatically gives you, so instead of having to type math BBR every time, so it automatically gives you this kind of R. Okay. So, I mean, I think we should talk about these special characters when we get to our mini project. So there are some special R characters that you may want to use for, I mean, they are really fanciful for if you want to do the fancy math stuff, right? So new command. So instead of math BBR, anyway, you see backslash R, it's automatically math BBR. So for vex, you have this math bold font. So if you want your font to be bold, number one. So new command num and all this. So you can declare them. So and the usage will now be something like what you have here. That when you have a vector v in R cube and all these things, based on what you have declared before, then all of this can work for you. Okay. Then we have math accents, like maybe you need a cap for you need a hat, right? Or a bar or a tilde. So all of these things work. So X cap, Y bar, Z tilde, like that. But for whatever reason, I mean, this is used most of the times for say, yeah, maybe for vector or average or mean or like that, then tilde for whatever reason you want to use, mostly for vectors. Then numbering, referencing, and custom tags. So sometimes you can have manual equation tags instead of align LaTeX to do the tag for you. You can actually define your own tag. So in this case, now you have begin equation and equation x squared plus y squared equals z squared, and then you are doing a manual tag. So once you put backslash tag Pythagoras, so to tag it as that Pythagoras, we'll see that in the mini project. Then you can have cross-referencing. I think we saw an example of this before. So equation ref, e.g., EQ energy defines the energy mass relationship. So if you want a bracket for the equation number, you have EQ ref. If you don't want a bracket, you just have ref and without the EQ. Okay. Then you can have advanced math layouts, like maybe you want to talk about cases structures like you have here. So f of x is like you have a what we said the other time, step functions. So begin case is x squared when x is greater than or equal to 0 minus x when x is less than 0. So for case structure. We saw that before. Then for split, I think I talked about split the other time. So you have a long equation and you want to split it and you want certain things to align. Okay, I think I was way ahead of my time there, but it's okay. So we have the split thing here. We've done it before. Okay, so I guess I want to also display this directly here. Let me see if it works here because some of this should work. Yeah, I see that. So you can see the qualities aligning because of the ampersand that have been put together. So you have these two aligning. Yeah, we finally come to the mini project where we all the things we've been talking about, we now really see them for what they are. So we have a mathematical problem sheet now. So you have this whole thing. So I'll just copy this. Okay, before I copy it, let me know. Let me just show the other thing. So in case I forget to come back here later. So quick reference table now. So inline math, we already saw that we can use single dollar or even backslash, open brackets and all that. Should I do okay, let me take the pen to write it. So we can use this or we use this again. I mean, this dot dot dots, this, like this. So we can use this. Then come in here, we can also do or this, then double dollar, dot dot dots, double dollar, double dollar, like that. So we can do this. So like maybe a very good example is when you want to display this one separately. So you can have that integral, begin equation and equation. We have all of that. Align, gather, multi-line, we talked about that. Even I think split should even come under this because it helps us to work with multiple equations. Then for matrix, you can have P matrix, B matrix, V matrix, capital B matrix, capital V matrix, and the rest of them. Delimiters you can have left and right. Don't forget ever left and right will so for whatever delimiter, maybe brackets, even horizontal, vertical bars. So left and right will do a perfect job for you for horizontal, for vertical bars, for instance. Let's see. The other time when we used the delimiters, yeah, I mean, okay, this is what I mean by vertical bars. So let's say I still come here and I have comma and this is quad, okay? I have quad and then I now have left again, left vertical bar, all right? Then right, right, vertical bar, okay? And in between that is the right vertical bar. And in between that, I now have, say, what can I have now? So let me say I have, okay, I want to do something crazy. Frac this, this. Then let's say this is x squared plus y squared. But even here, I now want to have a squared plus, okay, now I want to have another frac right inside here. Frac, okay, frac, this, and it can really be complicated if you don't understand the flow. A squared plus b squared plus c all over dx squared plus ex plus f. Okay, that's like double layer of fraction. You can see that. So once you put left and right, it automatically just takes care, no matter how long the height is. So it automatically just takes care of the whole thing. All right. So let me just add this to the other example down here. So this is what this is going to look like now. Okay. So even this vertical thing is a delimiter that works pretty good here. So yeah, so these are some examples. Then you can also have some custom macros and operators. So some practical exercises, you can type the Euler's identity, both inline and display style, write and align three equations using align and label each one, construct a 3x3 matrix and compute its determinant. All right, so you can go step by step. Define a new operator \tr for matrix trace and use it in an equation. Then create a small document combining fractions, roots, and piecewise definition. So let's go back to our mini project. Okay, so just copy the whole of that. And I take it to Overleaf. Overleaf is pretty easy to use because you don't have to install anything. But anything you do in Overleaf, you can just copy exactly the same code to say Text Studio or TechWorks, and you still run it exactly the same without stress. All right. So, I mean, Tech, all these other ones are really good because if you don't have internet, you don't have to be stranded. Okay. So here now, so we have autocompile and that helps pretty much. So you can see all the equations are showing here now. So what do we need to know? So we see um, okay, let's even look at the codes. So first of all, we have AMS math, AMS symbols. There are more math things like AMS fonts, AMS THM for theorems, as you're going to see later. Then we have sample problem set, algebra and calculus. Problem one, solve for x. And then we have 2x plus 5 equals 15. We label that as 1. X is fraction 15 minus 5 over 2 equals 5. That's equation 2. So from equation 2, we find x equals 5. Something like that. And then we compute the determinant, compute the determinant, and you have, so this is what dollar sign would have done for you too. So compute the determinant and V matrix now, because you're looking for determinants, that just takes care of that. Now for integral, this is how this whole thing goes. I think we need more things, right? What else should I add to this? Look, we already have matrices here. We have determinants here. Yeah, I think I was talking about that diffrac thing the other time. Okay, so normally we have backslash frac. Okay, yeah, backslash frac. Then we have this, right? Backslash frac. Say, okay, dy dx is equal to dy dx. Okay, of course, I need to put this within, let me put it in display format. That's double dollar. Okay, dy dx equals 4x minus 5y, 4x minus 5y. So we have this. It's in display format, right? So 4x minus 5y. And this is what that looks like right here. So what if we now want to have, so this is where the diffrac thing now comes in. So if I make it diffrac, so thank God for auto compilation. So you see the y dx in the second case, it's like the diffrac is not taking shape. Okay, good. Let me go here. Maybe I need more math stuff. So AMS maths, AMS sim, AMS fonts. Does this help anything? AMS THM, right? Maybe that doesn't help much, but it's okay. Let's see. But I know diffrac does makes things better if the equations are really heavy. Okay. Okay, I guess I can copy that delimiter thing I did the other time. Let me bring it here. For the delimiter. Okay, good. This right here. So imagine this home. So let's see if that makes any kind of difference at all. Okay, so this, okay, home, double dollar, and double dollar. And then, of course, we have automatic. So now see how small that looks. What if I now copy the same thing and I have, so instead of just that frac, I have dfrac and I have dfrac. So I think there should be a clear difference. Yeah, you see this? You can see this is way bigger than this. So once things are getting tinier, dfrac makes them larger. It's exactly the same equation, but this one is bigger because of dfrac that I used right there. So, I mean, you can, okay, let me just do one small thing. Say we have the solution to the quadratic equation. All right, so I can do inline now. So I'm used to dollar signs, but you can use the alternative. The equation of a quadratic equation is ax. The solution to the quadratic equation, ax squared plus bx plus c equals 0 is, so I also do it inline, is x equals uh frac, x equals frac. So I have this. So that's minus b. Now, plus or minus is backslash PM, plus or minus square root. So plus or minus square root, then open and close bracket, plus or minus square root of b squared minus 4ac. All right. So, and that's just it. So you see, that is inline. Okay, 4ac divided by 2 divided by frac this. Okay, I have to finish up. Divided by 2a, yeah? Divided by 2a. Okay, so we have this now. So everything is inline here, okay? But then I can just take the same thing and make it display, okay? So to display that, I just add $1 sign here, add $1 sign here, and then for the other one, I add $1 sign, and then lastly, I also add $1 sign to this. So, and then you see everything is split up. Okay. So the equation of the solution to the quadratic equation is this. Now you see the way this one looks now. What if I now copy this again and now do that diffrac thing I said the other time? Okay. So I have this. So instead of just having frac, I have diffrac. So after compilation, you see that the last one looks bigger than the previous one. So this one looks more legible, I think, compared to this. Although the difference may be a bit subtle. Okay. Yeah, so what else do I need to do as far as maths is concerned? Yeah, I mean you need to know different symbols like say plus or minus. As you can see, plus or minus is backslash PM. Okay, we have minus or plus is back. So yeah, it has to be in dollar sign. Any math thing you're doing should be within that dollar sign, whether inline or display. Oh, minus or plus is backslash MP. All right. So you have so minus or plus. Minus comes first. So you can see this is, you look at it here now. So plus, minus, minus, plus. So all those things. Interestingly, if you copy this same thing to Text Studio, so if I copy this now, okay, and just bring it to Text Studio, so like I open a new document right here, and I paste it, okay, and I run it, so we get the same PDF document, okay, we get the same PDF document. So if we save it to automatically save into the folder we're working with. Okay, that's a LaTeX typesetting folder. But the beautiful thing about this one is that you can already see some of the symbols here attached to this. So you can you see the plus or minus thing. Then you also see the minus or plus one, plus minus, minus plus. So different things. If you need times, like say you need let me imagine you need 4 times 4. Okay. Of course, that will be within dollar sign. So you have 4 backslash times. Okay, or you can just click on that and you just jump out times 4. Then that just works out like that. So you see 4 times 4 right here. So that's 4 times 4. So you have all these plenty symbols, all the double integral, cos, tan. You can just use them freely. Okay. Maybe along the line, we will do it like a math text and you see how that goes. Okay. So I think I want to stop here. It's been a long video. Okay. Thank you so much for listening to this. This is LaTeX Mathematics Fundamentals. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. So, well, if you can master all these things I've said, you're going to really like it using LaTeX for typesetting mathematics like that. So let me know what any other thing you think I should do. Don't forget your practice exercises. What else? Yeah. So don't forget to subscribe if you haven't done that already and hit the notification bell so you can always get alerted each time a new video is released. Having done that, don't forget you can also become a member of the channel by clicking on join, and that comes with some special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. So I come your way again. Keep doing maths right. In the next video, I'll be talking about some more maths things like some general maths operators and all that. So watch out for that. Bye.